You're live.
Hey everyone, I think we're live here on LinkedIn, so I'll just give this a few minutes. Hope you guys can see us there live. Nice to have you guys on board on a Thursday afternoon, right around Australia, across the world, wherever you guys are. I'm just going to check that everything's working. So just so you guys know, LinkedIn is still in the testing phase with LinkedIn Live. So some of the functions are not 100% working. So I'm just going to bring the feed up just to make sure I can see what you guys can see is all good. And there we are. Got Dave and myself on. Carol, how you doing? Really nice to see you guys. So as promised, today, joined by Dave Picone from Telford Smith Engineering. Some of you know Dave on LinkedIn, and for those of you that don't, I'm going to let Dave introduce himself very, very shortly. But they're a family-run business with 97 years of trading history in the plastics industry, whether that's in building recycling equipment, supplying recycling equipment in the wash plants, also extrusion equipment, balers, shredders, grinders, you name it. When it comes to recycling, Telford Smith have been there from the start. So thanks so much, Dave, for making the time to come on, and really appreciate you coming on and sharing some knowledge today with our audience. I'll hand over to you, mate, and just a bit of an introduction from yourself.
No problem. Thanks, Simon. Good to be on. Meet everyone. I hope there's plenty of people out there listening. So, as Simon said, Telford Smith Engineering, we've been around since 1923, so we've got a few runs on the board. Apart from about 2 years in the middle somewhere, it's always been a privately owned Australian business. It's never been owned offshore, which is a good thing. It's been in my family since the year 2000, and it came together and combined with our family business, which is CTS Plastics Machinery, which has been around about 45 years now. So there's a lot of history between those two companies in Australian plastics manufacturing and recycling. So CTS actually made granulators for about 35 years, as well as a whole lot of other plastics processing machinery like extruders. We sold shredders for a long time. And then Telford Smith is an old food manufacturing company which made homogenizers and mixers. So when plastics and rubber came to Australia through the 40s and 50s, then the first companies approached to manufacture rubber and plastics extruders. So we've made extruders since the 1940s in Australia, and we haven't had a 1958 extruder back just 6 months ago to be reconditioned. Original gearbox and frame, and we put a new screw and barrel and feed drive on it. So yeah, plenty of history there.
Yeah, absolutely, Dave. I mean, I've visited your factory a few times, and you guys do have a lot of equipment there that is actually from a long time ago that is still making plastic product today. And it's amazing how robust that equipment obviously is, and it's a testament, to your business and obviously the customers that you've had over a 97-year period.
Hang on,
So, have I lost you there, Dave?
I'm back. I lost you there for a sec.
You're back. Okay, sorry about that, guys. So, I was just saying to Dave that, I've visited his factory numerous times, and they do. I often see a lot of the older extrusion equipment there that does get rebuilt, and it is a testament to your business of being there for 97 years that a lot of this equipment and customers, are still coming. Is a great testament to you guys.
Yeah, definitely. It's something I think we've built a bit of a reputation on. Some might say over-engineered. We like to think it's robust and going to stand the test of time. Our sort of general feeling when we, build a machine and design a machine for Australian conditions, which I think are different than everywhere else in the world, is when a customer comes to us, they want one machine that can do 20 jobs, where, for the international market, they want 20 machines to do one job. And, we see that, we've got some manufacturing in China. We go to see companies over there and they're making 100 extruders or 100 granulators to make one profile. Where if we sell an extruder for a profile in Australia, it's got to run 10 different profiles in a week. So it's got to be robust and be able to stand up to all that abuse that gets thrown at it in Australia.
Yeah, we obviously have a really different marketplace here. Dave, just jumping into recycling, and I want to try and, step everyone through this step by step, because, recycling can be quite complex. It also can be simple, and I want to try and put this in real simple terms for everyone, and we can kind of dive deep into a couple of these areas. And with all the talk about more infrastructure needed across the world so we can recycle more plastic, one of the key pieces of infrastructure that is going to be required is certainly more wash plants. And perhaps if we start off with talking about a product that everyone is familiar with, it's well documented, and that's the PET bottle. And how you take a PET bottle from its raw form and then produce a flake, or even get it back to food grade resin. And I don't probably want to into the food grade resin part today, because I want to talk about really your expertise in washing this material and getting it back to flake form, and what's actually involved. So, what when it comes to wash plants, what are some of the main things that people need to consider from the outset? What are some of those questions you would be asking of them to start with if they come and inquire to you about a wash plant?
Oh, look, the first question I'm going to ask you, Simon, you call me up and you say, Dave, I want to wash PET bottles, or I want, usually it's we want to wash bottles, and then so the first question is it PET or HDPE? Is it mixed material? And okay, so for this example, you're going to say PET, and I'm going to go, okay, Simon, so your PET bottles, and this will sit really well with you, is what percentage of those bottles are PET? And they always say, 100%. They're bales of PET bottles. And I'm going to go, yeah, but a good bale of PET bottles is like 95%. But really probably only 90%. A lot of the MRF manufacturers out there listening might disagree. The new MRFs will quote 95 to 98% for a brand new one with the latest technology. But that's in, ideal running circumstances. We know most of the MRFs in Australia are running over capacity because they're getting pushed harder and harder, and there's so much contamination in there. So they just can't run efficiently when the general public's putting a lot of rubbish in. So first thing I need to understand is how much rubbish is in your material.
Yeah. So Dave, again, it all starts at the beginning, right? And so understanding the feedstock that they want. So if they come to you and say, hey, we want to build a wash plant, really the first few questions you're asking is, okay, well, what are you actually washing? That's what you're getting to, is what are we actually going to be washing, and what's the feedstock going to be, right?
That's exactly right. Sorry if I'm talking over you. I think you might have paused a little bit, but so I'm saying to people, we need an in-detail analysis on that material. So if you're getting material from 4 or 5 different sources, I'm going to be saying you should be getting a bale of material from that MRF every week for a month or for 2 months, or until you give me the order. Just keep doing it regularly. Get a bale, pull it apart, all 500 kilos of it, or however much that bale weighs, lay it out on the ground, put the rags over there, the aluminium cans over there, and weigh it all. Work it out for yourself. And you'd be surprised how many people don't do that, and they don't know. Or they'll spend $5 or $6 million on a plant, and they'll go, gee, why isn't this working? And I'm like, well, look at all the aluminium cans and everything in there. This is what you said they didn't exist. If we knew it was full of aluminium cans, we could have put in a little bit of different equipment that would have taken care of that. So it's really important to understand your material and get a good assessment done. And that doesn't mean analysing one bale or analysing 10 kilos from a few different bales. And every source is different. Yep. So if you go to one MRF, the material at a different MRF is going to be different. And it can even vary seasonally, but then we're getting a bit too picky.
Yeah, absolutely. So Dave, so once you've got your material feedstock, and just to give that some context for everyone, once a bale enters a wash plant, let's kind of walk everyone through that so they understand what actually happens. And I know it will vary depending on that feedstock, but let's step people through that to understand the process in raw terms, and just give them some idea of what really happens in one of these plants. So, when someone says to me, "Oh, wow, it costs $5 million," this is why it costs $5 million, or whatever the cost is, depending on the size, right? But can we step everyone through that, Dave, of step by step? I know we had some other images that I wanted to share, but I had a few problems sharing that before the broadcast.
Yeah, look, you just froze up a sec at the end. I can share my screen, but there's two distinct different wash plants we have. We have like a basic cold wash plant if the customer is only after like what we call industrial grade PET flake out the end. And then there's the full, what we call a bottle wash line, where it's producing a flake suitable for to going into another process to make another bottle again. So they do vary quite a lot. I think I should be able to share my screen. So let me just get that going.
Yeah, that'll be awesome, Dave. While you're getting that up, Dave, I've just got a quick question from Sylvia Garner. She'd like to know if you have portable equipment that can shred and wash PE agricultural mulch. I think we'll cover that in a minute. Sylvia, there is some mobile equipment out there, but I'll let Dave jump into that after. Back over to you, Dave.
Yeah, I didn't have a chance to tell you before we jumped online, but when I lined up my information to share my screen, I snuck one on the end here, which is our mobile wash plants we've been developing. I thought people might be interested in. So these are containerized systems for shredding and washing. So we'll jump to that at the end, and I can help Sylvia out then.
Okay, thanks, mate.
Okay, so starting at the start, basic wash plant for bottles. So at the top of this, it says HDPE milk bottles. We can do a very similar thing for PET bottles if it's just industrial grade and you're feeding in a pure stream of bottles. So this is, I'm not sure if you can see my cursor, but over on the right-hand side, you've got the conveyor feeding up into a wet granulator. So that wet granulator has two big augers in the top, and that pushes the bottles down into the granulator rotor. The reason we do that is because bottles are very light and fluffy, so they like to float up and down on top of the blades and not go through. So we get about 50 to 100% more output by having the auger feed hopper on the top of the granulator. So while the bottles are getting cut up in the granulator and they come out in about a 10 millimeter piece, we're flooding that chamber with water, and we're using all that aggressive action to wash the plastic at the same time. So, and then out of the granulator, it floods down there into the float sink tank, or the sink swim tank. So if it was HDPE bottles, the material is floating across the top. If it was PET bottles, the PET would be sinking to the bottom. And what that's doing is it's separating it from other polymers. So when you're running HDPE, you're sinking off the PET, and you're sinking off any rocks and heavy metal contamination. The PET, which is what we're talking about, would be going to the bottom of a similar sink swim tank, and then the HDPE bottles and all the bottle caps and collars will be floating and separating them from the PET. That material then comes out of the bottom of the sink swim tank and goes up a friction washer, which is a high-speed agitation. It's doing about 1,000 RPM, spinning around and conveying the material up into the mechanical dryer, where we're literally just spinning off the water to make it dry before we put it into a bag, because the downstream processes really don't like moisture. So drying is always a very critical part of any wash plant.
And Dave, I hope you're delaying me just jumping in here. I guess, there is that key principle here that everyone needs to remember, that no matter how good that equipment is, and it is great equipment, but like you said, there are systems built to remove contaminants, but you'll be more efficient in running a wash plant if you've got better quality input feeds, right?
Yeah, 100%. 100%. And I've just flicked to another.
So now while you're doing that, Dave, I'll just quickly message everyone out here. the image you got on screen at the moment is the PET bottle wash plant. And I am familiar with this kind of layout. I've been into a few plants that actually have your equipment with this similar layout. So again, can we run through this, Dave? If everyone notices over there out like in an L shape and a leg is actually the in-feed side. So Dave, you want to step everyone through this and maybe what we can talk about here is some of the technology that you guys have got in here. One of the things that I often talk about is quality control, not only on the input, but also on the side of the finished product. But there's some other little bits of technology in here that help do a bit of sorting as well. So Dave, if you can step everyone through this one, this is a PET bottle washing plant.
Yeah, definitely. So as you saw that last slide I had up, with quite a basic wash plant. I think there's 5 pieces of equipment in it. Very robust machinery and good at what it does. But when you want to do PET food grade, every step is critical. And I get this plant here would be suitable for running that sort of 90-95% pure PET bottles. Maybe even 15% contamination in some cases, depending on what they needed at the end. But coming in the start, we're going into a big shredder, which we're calling a bale breaker. So it's peeling all the bottles apart. Those bales, when they come in, are very compacted and they like coming in big sheets. So we need to singulate them before we can treat them. So after going through the bale breaker, we go into a trommel. I think most people will be familiar with a trommel, but it's a great big rotating drum with, say, 50 mil holes in it. So any loose bottle caps and collars will fall through. Any rocks and glass that might be on the bottles, because we get a lot of glass contamination on the plastic bottles, which affects our plants. So that's one of the Australian MRF problems people might be familiar with, but we try and get rid of that as much as we can. If you can see my cursor coming out of the trommel, we have we will have a suction hood there. It's not really shown, but there'll be a suction hood there which will suck out any films. If there's any loose labels or any plastic bags in there, we'll try and suck them out. And we'll have an overband magnet, which will then just take it, if there's any metal cans in there or anything else that's ended up in there that shouldn't be, hopefully the magnet can pull that out. The next step is we come up really high in the air and we have a label peeler. So the flattened bottles will go through a label peeler, and that scratches as the bottles are being passed through a thin tolerance. The labels are all scratched and peeled off. And that actually does a very good job. Not only does it remove about 99% of all the labels, but it removes most of the caps and collars at the same time. So that's an important process. Now, underneath there, we have
So Dave, just to jump in really quickly, sorry to step in there. At this point in the wash plant, Dave, what's really interesting for everyone out there to know is that it's actually built into a PET wash plant to remove the cap and that little collar that's left on the cap, as well as the label. So, quite often we hear stories about, should the cap be on or off? It's not recyclable. Well, guess what? A plant like Dave's showing everyone today, it removed the cap and that little collar off the PET bottle. And by the way, that material is not thrown away. That material is then, taken off the line somewhere else and can be separated and again turned into another commodity or into another product again. So to quickly just highlight that to everyone, because there has been a lot of talk in the media and out there about whether the caps should be on, caps should be off, are they recyclable? And there is this myth that caps aren't recyclable, but the fact is they are. And there's equipment that does remove the cap and it gets taken off and turned into another product. So yeah, back over to you, Dave, as we move towards one of my favorite bits of kit that you guys have got in this particular plant.
Yeah, we're getting up to it. But yeah, for sure, removing the caps and collars is important. And unfortunately, particularly in Australia, we're never going to convince all the public to remove the caps and collars. So unless 100% of the people did it, we've got to have the equipment in there and the machinery in there to deal with it. So from my point of view, our plant, I don't think it makes any difference if 100% of the bottles have the caps and collars on there. So I know I always leave mine on when I put them in the bin. And there's several processes in here where that material will be separated. So as Simon was saying, after the label peeler, we have a ballistic separator. That's just literally separating the light stuff and the small stuff from the bottles. Bottles then go over an eddy current separator, which isn't in every plant. It's in most of the plants in Australia because we have a lot of aluminium contamination. And again, that depends where you're getting your material from and what the quality of that MRF is like. So that's when you need to be talking to someone like Simon and finding out how good a quality are these bales of bottles and what contamination am I likely to get. One of our customers in Australia, this eddy current separator, which pulls out aluminium cans, he said he paid for it in about the first 4 months with aluminium, and that's a pretty expensive bit of a kit. That's how much aluminium contamination he was getting in his bales. I think his biggest problem was he wasn't making any money on anything else because there was so much contamination in his bales. But I think Simon might have helped him out eventually. After the eddy current separator, you're going up to the bottle sorters. Now, these are amazing bits of equipment. So they're using 3 different bits of technology on a single machine to separate and clean up the bottle stream. So the first thing it does is it passes under a color sensor, and that color sensor will detect any green PET or anything other than, say, clear PET or light blue, because that's generally what we're targeting in these wash plants is clear or light blue PET. It then passes over a metal sensor, so if there's any aluminium in there or any metal of any description, it will sense that. And then it will pass under an NIR sensor. So the NIR sensor is near infrared, and it detects that it is PET or it is HDPE or polypropylene or PVC. So we can tell that bottle sorter that we only want clear PET and everything else gets ejected. So in this case, we have 2 different bottle sorters in a row. Sometimes we have 3, and that's because we're being particular about how we want it, and we might be taking out all the HDPE in the first pass so that can go to a separate wash plant, and then in the second pass, we're taking out all the PET so that it can go forward through the washing plant. So you got anything to add there, Simon?
So those bits of kit, everyone, I have seen this particular layout in operation, like I said before, and those 2 pieces of kit, Cessatec, which is German, correct, Dave?
Yeah, that's correct. Yeah, the German, we're the agents for them in Australia, but yeah, they're probably number 1 in the world in plastic sorting.
Yeah, and so guys, really, in layman's terms, what those pieces of kit do is, they're basically sent, they're set to detect what type of plastic it is, and like David said, you can set them for a bunch of whole different parameters. So if you want those sensors to pick up PET bottles, like David said, what will happen is it'll detect the PET bottle, and in a split second, it'll shoot some air, and it might eject that PET bottle off to another line, which then would go somewhere else, like Dave mentioned with the HDPE. So an incredible piece of equipment, and this kind of equipment is what you'll see in material recovery facilities all around Australia as well. This gear is a bit more specialised, particularly when you get to the back end of a wash plant. So, Dave, I'll let you keep moving it along here. Out of those Cessatec sorters, we're starting to now get into the grinding, the washing. How does that material flow after you leave those sensors?
Yeah, you're right. We're actually about to get to the wash plant now. So after the sorters, we've got a clean stream of PET bottles where we go past a manual sorting station. So we always have, even on a plant like this, 1 or 2 people standing there just pulling out anything that may have been missed. We like to give it, because the output of this plant for food grade PET, for a bit of perspective, is less than 50 parts per million contamination from PVC. So, and there's similar ratios of aluminium, et cetera. So you can imagine that if 1 aluminium can got through or 1 PVC bottle got through, that's hundreds and hundreds of pieces that we then need to separate later on. So manual sorting station, very important. The next bit is the wash granulators and the mechanical dryers. We have 2 running side by side, so we can have 1 running and 1 down for maintenance. So you need to be changing a set of blades on one of them every 3 to 5 days, depending on the output of your plant, just to maintain that peak output. So it's very important for high output plant that you have two running side by side. After that, we go into a storage silo, which allows us to meter the feed into hot washing. So hot washing is a critical step for achieving food grade standards. The main reason for that is that the glues on a PET bottle and a HDPE bottle can be quite difficult to remove. So we've got to keep them above about 70 or 80 degrees for 15 minutes. So we do that in a two-stage process to make sure we get the 15 minutes and be able to guarantee that to the customer and their customers. And we're also using a caustic solution at the same time. So you see down the bottom there, we've got the two red stations, they're the hot washers, and they're both followed by mechanical dry so that we can keep that water circuit together with each one of them, and we're not losing that caustic solution, which can be expensive to treat in your water treatment. We then go into a very interesting bit of technology, which is our sink float separation. Now, PET sinks, so does PVC. So when we're doing PET, we can't use our float sink separation tank that we showed earlier. It's a different style of system, and that will take off all the caps and collars that have been missed and made it through the system. And they're all granulated up in 8mm pieces or 10mm pieces, so it's pretty important we get them out. So they will float out, and they actually go through a different mechanical dryer, and they'll go into a bag at the end so that they can be recycled and sent to someone else to be used. And then all the sinking material, which is the PET, will then pass through the next mechanical dryer and a cold rinsing station. So we've got to rinse off that caustic water, make sure we really dilute it, anything might be left on those bottles down before we do the final dry. So after that's done, we do a two-stage drying process, and then we're passing it through a Cyclone Separator. Some people use zigzag separators. Some people will use like a ballistic separator to suck up the fines. We use a Cyclone Separator because our batch testing showed it's the most accurate. And that sucks out all the labels and any fines that have been generated throughout the line. It really does an amazing job at pulling out any labels that are loose.
Hey Dave, got a quick question from Anthony Payton, and it's a really good one, and you might not be able to answer it on the spot. But Anthony's asked, Can an NIR easily make distinction between a PET bottle and a PET thermoform tray, i.e. with the lower IV that you often get? So, Dave, is the technology there to be able to do that in a bottle wash plant with the Cessatec equipment, for example? Is that something you can answer, or is that something you'd like to come back to? Great question, Anthony.
Yeah, look, definitely I can answer that question. One of the functions of the color sorters is it's actually color and shape sensor. So it's detecting the shape of the bottle, and in most cases it will detect the shape and detect that it's got a label on it. So it'll know that it's PET with a strip of PVC or a strip of polypropylene through the middle, and it knows that it's a bottle. In this wash plant and in most of the other ones I've seen in Australia, they are pulling out anything that's not a bottle. It's not the right grade of PE, not the right grade of material. Anything that's not a bottle, we don't want. And yeah, the sorters can definitely remove that, and it can tell. And that's one of the other reasons we have got the manual sorting station there, because if it did fool the system and get through because of the way it was shaped, the operator can pull that out. Because one of the things we're concerned about is the other materials and the layers, where you have a meat tray that might have a different layer underneath it or in the middle of it.
Yeah. It's also just worth noting, Anthony's just thrown another comment in here, and it is a very good comment that, the APCO decision on bottles and stuff was heavily driven, by the CDS scheme managers. So, I think that's worth noting in this as well. Just going back to the issue on bottles. So, some great comments there, Anthony, and really appreciate you jumping in here, mate. Dave, we're now at the stage where material being all washed, we're drying it, and there's some great technology, and I've been into a few plants where they don't have this technology, right? But are at the back end of a wash plant for PET. What's some of the equipment that you've got in here after this material comes out from those cyclones?
Yeah, well, this bit's critical, and I might just jump to. No, I don't have the slide here. This bit's critical to getting the quality right. We find a lot of the contamination, and this is some sort of good trade secrets here. A lot of the contamination is in the fines. The fines are when you granulate material and handle plastics, you end up with fines which are, say, less than 1 or 2 millimeters. And they're very hard to sort out, and they get stuck to other bits and they get carried through. So when you're sinking PET, you might get a 2 millimeter piece of HDPE stuck to it, for example. So they're very hard to separate. So we use the Cyclone Separator, which sucks out everything that's light and fluffy, and then we pass it over a vibrating table with a 2 millimeter or 3 millimeter mesh in the bottom of it, and then let anything small fall through there. That's a very critical step. It's probably one of the cheapest bits in the whole line, and it has the greatest impact on your quality. So after there, we feed good, clean, dry, no fines, no lights and fluffy flake into the next Cessatec machine, which is the flake purifier. This is one of the best bits of technology I've ever seen, and I think it's critical in any PET line like this. So it'll detect the same as the bottle sorters, near infrared to detect the type of polymer. It'll detect the color, and it will detect if there's any metal. And that material is literally cascading over a waterfall past the sensors, and it's using air jets to shoot individual flakes out of the flow to purify it. And what we do is we have those jets running really aggressively.
Sorry to jump in again, Dave. One of the things I made a comment on one of the social channels in leading up to this is well worth everyone knowing that, when you get to this part of a bottle washing plant, we get up to this flake sorting, we're talking about sorting a piece of flake, in some cases the size of your little fingernail. So, this equipment is very highly skilled, if you want to put it that way, at being able to identify different polymers on a piece of plastic the size of your fingernail.
Yeah, definitely. If anyone's interested, I can send them a link. Cessatec have got some amazing videos on their YouTube channel, full HD, ultra slow motion, showing the pieces coming over, and you can see the coloured piece coming, and then the air jet shooting it out. It is really, really amazing. So yeah,
Dave, we end up. Sorry, Dave, go for it, mate. I cut you off then with the little delay we've got.
Yeah, it keeps getting me too. Okay, so yeah, so after the sorter, we're really aggressive with that, and everything that gets shot out, we shoot out so much that we end up taking out some good material with it. So that material then recirculates back around and comes into a different chute down the side of the sorter, and we resort it a second time just to really make sure that we're gaining the maximum efficiency of the plant, because you can imagine these plants are running at call it 1.5 ton an hour. You lose 2% on 1.5 ton an hour, and you're running 24/7. That's a lot of material to be losing, and not only that, it's contaminating your other material streams that you might be able to sell. So all these little steps that keep that 1% of material in the process make a huge difference. So then from there, we're going into the bags.
Yep. And then Dave, that product's ready to be sold back to a manufacturer who is going to make that into a food tray, or back into a bottle, or potentially into fiber to make clothing. The circular economy is a really big wheel to turn. And, a plant the size that you've just showed everyone there, Dave, I mean, I'm not asking for the exact figure, but, what is a plant like that worth? What is the investment to make to build a plant like that from the outset? And what's really worth noting here for everyone is, this is highly reliant on the type of feedstock that you have as well, like I mentioned at the start. And there's a bit of a saying that if you put rubbish in, you may get rubbish out, or you will have a higher cost of transforming that material into something. So Dave, just on that plant, what's a ballpark figure that someone's going to have to spend to be able to build a plant like that?
Look, it really depends on the output of the plant. So I will give you a straight answer, but the reason there'll be a large variance in the price is because of the output. So it can range anywhere between $5 million and up to, say, $10 million. And that's from, say, 1 ton an hour up to 3 ton an hour.
Yeah.
It's a lot of money, but, there's a lot of material going through these plants, and they run 24/7.
Yeah, it's a big job. So Dave, we'll spin a little bit about bottles. We hear a lot about LDPE film, and film being able to recycle LDPE films through wash plants. I know your specialty is bottles, but I just want to branch out just a little bit for everyone. A bit of context on how complex to recycle some of these materials can be, or how different that they are to recycle.
Yeah, film's very, very difficult. We cringe a little bit when we get inquiries for it. And again, the same as the bottles, the important thing to know at the start is what your feedstock is and how much contamination there is, because there's a big difference between shrink wrap that's collected from a large manufacturing facility where it's unwrapped from pallets of stuff and put into a bag, compared to shrink wrap film that might be coming from farms and off bales, and it's been sitting in the mud. And by weight, I've seen these bales come in, the bale weighs a ton and it's 600 kilos of dirt. So it's really important as to where the material is coming from and then what you're trying to achieve. The difficult thing with recycling film, I think, I'm not a recycler, I just make the machinery, but when you're talking about bottles, PET's got high value. PE film's got lower value, so it's cheaper to get in the first place, which is, I think, the attraction for a lot of people, but it's also got a lower sell price too down the other end. And I think it's harder to process than bottles, even if it's less complex. But the biggest challenge is drying the material after it's been washed.
Yeah. So Dave, just again, I just want to come back to some of these really important questions that people need to be aware of when they go and speak to someone about a wash plant. We made a quick list of these beforehand based on some of the comments that we did get. And I'm just going to quickly thank a couple of people who've jumped in the comments. We've got Carol on from our UK team. We've got Sylvia. We've got Anthony there. We've got Darren North as well. I hope I didn't miss anyone. I'm not sure the delay on the LinkedIn live feed. So thank you very much. And thanks to everyone who's actually tuned in and watched. And I hope you got some value out of listening to Dave's explanation of a wash plant. But the important things to know when acquiring a wash plant, I'm going to just throw these at you, Dave, and you maybe give a bit of detail around it, and then we'll work towards finishing off. But, the first one was, and we've covered this a little bit, is know what your input material is in detail, right? That's the first step, right?
Yeah, 100%. You got to know what your input material is and how much contamination is in there. Everyone likes to say, "Oh, surely you know," but it can vary so much.
Yeah. And the second point we've got here is, know what you want to produce as a final product, whether you're producing pellets, a flake, a hot wash flake, what's the finished product you're trying to make? And so many people want to jump into things and start washing and making a product, but they don't know what they want to make. And that's probably going to be more driven by who they think their potential customers are, right?
Yeah, look, that's exactly right. A lot of people call me up, "Oh, look, we want to get into recycling," and that's great. I'm never going to criticize anyone for that. But they say, what can we make? I'm like, well, that's your business. You gotta know what you want to make. If you tell me you want to make, bollards or fence posts, I can sell you the machine to do that, and you don't need a full PET wash plant to get there. If you want to make bottles, again, I can get you there also. If you want to make film, I can do that for you. But if you want a machine that can do everything, or you don't know what you want, it's very hard for me to know where to start.
Yeah. I'm just going to throw a quick question in here, Dave. Anthony's got another good question here. He's just mentioned, what about film dry cleaning? Is it better? I don't know enough about that, and perhaps I might get David. I will intend to get David Hodge on here at some stage, because he certainly knows something about that. But I just thought I'd throw that at you, as we've definitely got a quick question there from Anthony about dry cleaning.
Look, I don't know a lot about it. I have spoken to some people doing it, and they say, it's got its advantages and disadvantages. Of course, the major advantage is drying the material. If it's not wet to begin with, you don't have to worry about drying it, which is very power intensive and very, very expensive and difficult to do. I don't believe you get it as clean as what you would if you were using water. So that's one of those things where it depends on what you want to produce. If you want to produce a railway sleeper, a fence post, bit of dirt doesn't matter. In fact, we've had applications where don't even worry about washing it. If we know what you want to make and it's a fence post, well, let's just leave all the dirt in there. It's just filler. It's just going to get melted into the material, and we'll deal with it separately and save yourself $1 million on a wash plant. So particularly with film, that they're the discussions I like to have is, do you actually need to wash it?
Yeah, all about that input on the feed side. And I will get Dave Hodge on here too, by the way. So if Dave's watching, expect a phone call. Quick question for Eden Despiro here. Dave, Eden's asked, the liquids used in washing, when would it need to be replaced? Does it have a small water treatment plant? Now, I know the answer to that, and I know you work with the Aerofloat as well, but Dave, you want to just give a quick bit of context to that? Thanks for the question too, Eden.
Yeah, look, water treatment is 100% critical, particularly, the plant that we're looking at last there, the PET wash plant. If you don't have good water treatment, you won't meet the standard you need to produce good quality flake. It's not a small water treatment plant. It's a big water treatment plant. On a 1.5 ton PET line, you could be spending anywhere up, over $500,000, and that's treating that water. We have a couple of different water circuits in our PET plant. All the caustic water is treated and handled separately from the rest of the water. We have another clean water circuit we feed in at the end of the line for the rinsing, so that we're rinsing with the cleanest water, and then we're using the dirtier water that's been processed through the wash granulators, which is the first washing stage. Because, Simon, you grew up in the country, you can go for a swim in the dam and you come out pretty clean, don't you?
You do. Which leads us on that next point that we did make, Dave. So you've touched on a bit of the water treatment there, but another point that we did make early in discussion is, assessing whether that's space restrictions, okay? Because you can change the configuration of these plants, but also power. Power is a really big thing to talk about. Like we talk about sustainability and all the rest of it. People need to be aware of the kind of power that these places do need, right?
Yeah, that's exactly right. So, the electronic sorters and a lot of this equipment only have small motors, but you get to the granulators and you've got 132, 160 kilowatt motors on those granulators, and you have a couple of them running at a time. This wash plant has got, the PET one's got 7 mechanical dryers in it, all running at 22 to 30 kilowatts each. So there's a lot of juice being chewed there to get all that material and keep it moving and make sure it's wash coming out the other end, in addition to the heat for the hot washing, which quite often might be a boiler. So I usually ask people, how much power do you have, and is that a problem? Because I don't like getting to the end of the process after spending weeks talking with someone and they tell me they've only got 100 amps to play with, and we need 1,000 amps or 2,000 amps. And not just my time, but it's their time, and making sure they're talking about the right thing. And maybe there's solutions we can offer them that do fit into 100 amps if that's all they've got. Maybe they just need to start off with a small granulator and just to get into the industry and get started.
Yeah. Obviously, Dave, there are some real other key things here that people need to consider about wash plants. These are common questions I get all the time. We've kind of covered a little bit of it, giving some people some idea on the cost of the plant that you shared earlier. But budget. A lot of people are hesitant to say how much money they've got to spend, and it's not that you want to go and spend all their budget, but you need some tools to work with. It's like like looking for a product, a price range. You're better off sharing that in some way, so that the person that you're trying to work with knows what they've got to work with to start with. Because it's no point sending someone like David up a garden path designing a $10 million plant when all you've got is $5 million. He's going to be able to help you and solve your problem in a more meaningful way if you're open about a budget. That's something people are a bit hesitant to talk to you about up front, right?
Yeah, 100%. Sometimes I might be ask a bit too confrontingly and it gets taken the wrong way. But I've been doing this for 18 years, and you get to the end of a process, and you finally understand everything they're telling you they want to do, and you send them the quote, and it's $500,000 or $600,000, and they just go, "Oh mate, I don't have $500,000 or $600,000. Can you do it for $200,000 or $300,000?" And I'm like, "Well, I can't do that for $200,000 or $300,000." But and then we start looking at it, going, "Okay, well, for $200,000 or $300,000, why don't you just consider this? Rather than trying to produce, food grade HDPE, why don't you just take it back a step, just go industrial grade and make this? We can cut out 3/4 of the equipment. In fact, I can probably do it for $200,000 instead of $300,000, and you still can do 60 or 70% of the products you want to make." So yeah, really important to understand.
Yep. I'll just throw another comment here, guys. I am trying to, if you see me reach, I'm just reading some of the comments to try and engage with you guys as much as we can. Great point, Darren North. A big issue is education, educating the customer. Obviously, most think plastic is plastic, and there are some really poor examples where people haven't educated their customer properly who are in our industry. So definitely something worth thinking about. There are so many different materials, and it is really important that we are, being specific about what plastic that we've got or what plastic that we have, and can it be recycled. It's definitely something that we need to do, and it's certainly something that we've tried to really do a lot of is education and helping everyone understand more about plastic. And some of you guys may have heard me say this before, that by sharing our knowledge on plastic, we're bringing the whole industry on the journey with us, and the more we all share, the more everyone's educated about it, and the more everyone will be able to make better decisions in the future about plastic. So I really appreciate that comment coming in there, Darren. Dave, we'll probably wrap it up. We've been on air now for almost an hour. Probably missed out on, but we'll cover that maybe in a podcast at some stage soon as well. Is there anything else, Dave, that I've missed out before we wrap up here, mate, that you want to make mention of? Where can people come and find you if they want to know about what you do? What's the easiest way to get in contact with you?
Yeah, look, the best way to get in contact with me, you can send me an email, give me a call on my mobile number. All my details are on my LinkedIn profile all over it. Or else it's davidp@telfordsmith.com.au. Use my email address. Send me an email, give me a call. Simon's got my details. It shouldn't be too hard to find.
Dave, thank you so much for coming on today. Really appreciate it. Obviously, guys, LinkedIn Live is a new platform. It's still in the testing phase. It took us a little bit to work a few little things out to get Dave on screen. Just really appreciate you guys taking time out of your day to come and to listen to hopefully what's been educational for you. Certainly, you would have learned something from Dave. Really, really appreciate it. And we'll get in the comments after this and try and answer as many as we can. But again, thanks so much for joining us. And as always, with Van and beginning, not end, if you've got any questions, please come and hit me up with a DM. You guys know I'll reply to you as quick as I can. Have a great day, and I'll speak to you guys soon.